Why space is cold although the sun is hot. Our solar system is full of temperature extremes. The sun is a bolus of gas and fire. It measures around 27 million degrees Fahrenheit at its core. At its surface, the sun is 10,000 degrees Fahrenheit, but outer space is at the opposite end of the temperature spectrum. The cosmic background temperature hovers at minus 455 degrees Fahrenheit. How is it possible? Doesn't the sun heat it up? Scholars have puzzled over this paradox for ages. In fact, there's a reasonable explanation. Heat travels through the cosmos's radiation. It's an infrared wave of energy directed from hotter objects to cooler ones. The radiation waves excite molecules they come in contact with. This causes them to heat up. This is how heat travels from the sun to Earth. But there's a catch: radiation only heats molecules that are directly in its path. Everything else stays chilly. Take Mercury, for example. It's 1,000 degrees Fahrenheit colder at night than during the day there. On Earth, the air stays warm, even in the shade. In some seasons, it's even hot in the dark of night. That's because Earth is unheated by radiation alone. Heat travels throughout our planet by two other methods as well: conduction and convection. The sun's radiation hits and warms up molecules in our atmosphere. They pass that extra energy to the molecules around them. Those molecules then bump into and heat up their own neighbors. This heat transfer from molecule to molecule is called conduction. It's a chain reaction that warms areas outside of the sun's path. Space, however, is a vacuum, meaning it's basically empty. Gas molecules in space are too few and far apart to regularly collide. The sun does heat them with infrared waves, but transferring that heat via conduction isn't possible. Convection is a form of heat transfer that happens in the presence of gravity. It's important in dispersing warmth across Earth, but it doesn't happen in zero-G space. In 2021, NASA sent the Parker Solar Probe to the Sun. It got within 6.5 million miles of the inferno. The probe barely skirted the star's corona, but it's the closest a spacecraft has ever been to the Sun. The heat shield projected on one side of the probe made this possible. The shield absorbs solar radiation to protect the inside of the probe. It has experienced temperatures of around 250 degrees Fahrenheit, but the spacecraft itself stayed at around minus 238 degrees Fahrenheit. The extreme variation in temperature is a challenge for space engineers. Some spacecraft parts need help staying cool enough to avoid shorting out. Others require heating elements to keep them warm enough to function. Temperature shifts of hundreds of degrees sound wild, but it's just how things are out in space. The real oddity is Earth amidst the extreme cold and fiery heat. Our atmosphere keeps things surprisingly mild.